Hey class, this is Jesus. He's going to be doing your math lesson today. Alright, it's not really Jesus, it's Mrs. Norris, but I didn't want to start the video off the same way I always do, so I'm making it a little lively. I'm in the chapel today, so I thought I'd use some inspiration. Okay, so we're going to be doing Chapter 7, Section 1 today. Chapter 7, Section 1 is called Exponential Functions. And you're going to be hopefully a little bit excited because a lot of this chapter is something that we can model real life things and we can talk about real life things. So I'm excited about it. Basically what I want you to do is I want you to copy this function down. Yes, you should be taking notes in a notebook. I didn't tell you today to bring your book home. Everything you need I'm going to copy for you here or show you on the screen. So the first function I want you to write down is f of x equals big B, little x. The big B stands for the base, and the little x stands for the exponent. You've seen this many times, but now we're going to actually put an x in the exponent to talk about modeling data. You need to write that B must be greater than 0, and it can't be equal to 1. Okay, what does that mean? Well, the exponential function, if you want to jot some things down, has a couple of different variations. It's always curved like this. So this one is a growth example. And then I'll do a red function here. So when it starts higher and goes on this curve lower, then this is called a decay function. And they both keep going but never actually touch the axis. We call this axis actually an asymptote, which is a vocabulary word, so let's write that down. The asymptote is sometimes a dotted line. It's the line that the graph almost touches but doesn't. Okay? Almost touches but doesn't. So let's try a couple of these. What if I give you this function, 1.5 to the x, and I want you to determine with me if it's a growth function or a decay function. Well, we're going to look at the base. In this problem, my base is 1.5. If the base is greater than 1, then we say the function is growth. You could always type this in your calculator. We're going to practice doing that more tomorrow. But you will see that it looks like this black one here that starts low and goes up high. So obviously it's growing as time goes on. So as time goes more positive, my function goes up. Let's try another one here. Example B. Let's make example B P of x. That's just a new name. But let's put a 10 as a multiplier. And then let's make our base 3/4. Our exponent is still x. So again, we're looking at the base. Where's the base? The base is right here. It's not the 10, it's the thing that's being raised to the power. So since my b is less than 1, or a fraction, I say that this one matches the red graph, or decay. Okay, the next function I want you to write down, or formula, is we're going to be able to model how much we're going to have of something after a certain amount of time using this exponential function. So on the left side you're always going to have what we call the final amount. In the green you'll see that they're telling you that this is what you started with, how much you have at the beginning. And you're going to multiply it by 1, either plus the rate or 1 minus the rate. This 1 plus r and the 1 minus r are called the growth factor, and it's going to be based off, certain things. Cars depreciate, so of course we would use the bottom one, 1 minus r, or rate. Houses, however, appreciate, so those would model using the top equation, or 1 plus the rate. So we're going to finish these tomorrow, but I want you to at least practice writing the equation for some of these functions. This example here, like I said, we're going to finish in class tomorrow with our graphing calculators. But it's involving money, and it's involving an initial amount of $5,000. So if we take our template and we recognize the first phrase. All I've read is Clara investing money for $5,000, and that's her initial amount. I know right away that if I'm going to write this equation, I need to put that 5,000 where the little a is because it's my initial amount. The next part of the equation that I should write down is the rate. Remember, when you have a rate of 6.25%, that's the same as, if I want to convert it to a decimal, either dividing by 100 or moving the decimal over 2 places. Either way, you get 0.0625. That's my rate. So when I go back up here to my equation, I need to do 1 plus 0.0625. And you can realize that it's plus because she's investing money in an account that earns interest. The next part of the equation that we need to fill out is time. Well, time is our unknown. So you can put a t here if you want, but when we graph it on our graphing calculator tomorrow, we're going to use x for our variable. So we're basically saying a y equals here. Remember, y is just your final amount. And we're going to practice typing this in tomorrow and see what we can predict. Okay, this next one is talking about a city population, and it also has a starting amount. 1550 is the starting amount, and it also has an r. So we're going to write out the equation, a of t, t's time. So t's your input, your x value. It's equal to a starting point of 15,500. It has a decline in value because there's less people. It says it drops by 3%. And when I convert that 3% to a decimal, it looks like that. And I'm going to raise it to the t. You'll notice the answer here is given to us. And all they've done is they've simplified that 1 minus the 0.03. So when you type it in on your calculator, it really doesn't matter to me if you leave it as 1 minus 0.03, or if you put it as 0.97. You're both going to get the same amount as long as you remember to use my favorite thing, smiley face, sideways smiley face, parentheses. Okay, again, we're going to practice plugging this in our calculator. We can predict, as they asked us to do. Alright, as part of your homework tonight, I want you to try a couple of these. Number one, I want you just to tell me for A, go ahead and copy the functions down, A and B. I want you to write the function, and then behind the function I want you to say whether it's growth or decay. Remember, you're just looking at the big base, okay? You're not looking at the number in the front. Number two, I want you to tell me what growth factor means, either in terms of the equation or something. And number three, I want you to try to come up with one real-world example of something that appreciates and something that depreciates. Okay, I'll see you tomorrow.